Hey guys, it's Mr. C, and in this video we're going to be talking about some equations with fractions. And so what I'm going to do is I'm going to solve each of these equations using a method that I call clearing out fractions, most of them, and then some of the other ones we'll tackle those maybe differently. So for an equation like this, you could subtract the 4 on both sides and then multiply by 3, but there's an easier way to do this. And if you want to get rid of this fraction right here, you just have to multiply it by 3, because if you do that, the 1/3 and the 3 are going to cancel out. Or better yet, the 3 and the 3 will cancel out if you multiply. So what we're going to do is we're going to multiply everything by the common denominator, least common denominator of all the fractions in the problem. Well, there's only one fraction, and it has a 3 down here in the denominator. So we're going to multiply everything by 3, and then when we do that, plus 3 times 4 equals 3 times 9. All the fractions should cancel out. And so 3 and 3, these two 3's are going to cancel out because they're multiplicative inverses. So here, the only thing I have left is just 1x. 3 times 4 is 12, equals 9 times 3 is 27. And so now I have x plus 12 is equal to 27. So the only thing I really need to do is subtract 12 on both sides. So minus 12, and bring down my x equals, and 27 take away 12 should be 15. So it's a very easy way to get rid of fractions if you just don't like them and you want to just avoid fractions. Here's another one. This one has 1/8 in it. And so our denominators for the whole thing, there's only one, and it's 8. So we're going to multiply everything by 8, and we're going to get rid of this fraction right here. Minus 8 times 5 equals 8 times 3. So the only thing you really need to pay attention to is multiplying every term in the whole equation by the same number each time. Okay, so these two 8's cancel out. 1x minus 8 times 5 is 40 equals 8 times 3 is 24. That's a one-step equation. Plus 40 plus 40. Cancel those, and we get x is equal to, looks like 64. All right, here's another one. This one has 2 fractions in it, but they both have a denominator of 3. So I'm, again, going to multiply everything by that common denominator of 3. So I'm going to multiply 3 times 2/3 x, and it's okay if you put in parentheses, plus 3 times 1 equals 3 times 1/3. Okay, so 3 times 2/3. These two 3's are going to cancel out, and it leaves me 2x now for that term. Plus 3 times 1 is 3 equals, these two 3's cancel out, and it just leaves 1. So that's a two-step equation. Subtract 3, bring down my 2x equals -2, divide by 2, and it looks like x is going to be equal to -1 right there. So x equals -1, and we are done with that one. Okay, this one has 2 5's in it, so our common denominator is 5, and so we're going to multiply everything by 5. 5 times 1/5 x. Notice I didn't put it in parentheses this time. You can if you want to. I'm going to choose not to this time. Plus 5 times 10. I am going to put that in parentheses, or it's going to look weird after the 5. Equals 5 times 4/5. All right, so these two 5's cancel out. 1x plus 5 times 10 is 50 equals, these two 5's cancel out, and it leaves 4. So it's a one-step equation this time. We're going to subtract 50. Subtract 50. Cancel that out. I'm going to bring my x down, equals 4 take away 50 is going to be -46, and that is it for that one. Here's our next one. This one has 2 denominators of 2, so I'm going to multiply everything by 2 this time. So 2 times 1/2 equals 2 times 1/2 x minus 2 times 2. Okay, so 2 times 1/2 is equal to 1, equals 2 divided by 2 is again 1, 1x, minus 2 times 2 is 4. That's a one-step equation. I'm going to add 4 to both sides. Get rid of that 4, and 4 plus 1 is 5 is equal to x for that one. This time, I've got a 4 and a 3. So the least common denominator of 4 and 3 would be 12. So I'm going to multiply everything this time by 12. And let's see what happens. 12 times 3/4 x minus 12 times x over 3 equals 12 times 10 in parentheses. Okay, so now we have to talk about like this. 12 times 3 is 36. Divided by 4 would be 9. Or you could do 12 divided by 4 is 3, times 3 is 9. Let's do this. 12 times 3 is 36. Divided by 4 is 9, so 9x, okay, minus 12 divided by 3 is 4, and there's still an x there, so 4x equals 12 times 10 is 120. Okay, so now we've got 9x take away 4x is 5x equals 120. So now all we have to do is divide 120 by 5, like that. Those 5's cancel. And 120 divided by 5 should be 24. And we are done with that one. Okay, this time we have a 9 and an 18. And so the least common multiple of 9 and 18 is going to be 18. So we're going to multiply everything by 18. So 18 times. I'm about to multiply that by a negative number, so I am going to put this in parentheses this time. Negative 2 over 9x minus 18 times 4 equals 18 times 7 over 18. It looks like a lot to write, but it's going to condense down really quick. So 18 divided by 9 is 2, times negative 2 is negative 4x. Or you could do 18 times 2 is 36, divided by 9 is still 4. So negative 4x minus. Now we have 18 times 4, and 18 times 4 is 72 equals, these 18s are going to cancel, and I just get 7. So we're going to add 72 to both sides. Bring down my negative 4x equals 72 and 7 makes 79. Divide by negative 4. And x equals 79 over 4. And then just make it negative somewhere over there, just like that. This one has a 3, a 5, and a 15. So luckily 15 is a multiple of 3 and 5. So I'm going to multiply everything by 15. And that should clear out all the fractions. That's 2 plus 15 times 3x over 5 equals 15 times 31 over 15. Okay, 15 divided by 3 is 5, times 2 is 10, plus 15 divided by 5 is 3, and 3 times 3x is 9x, and equals 15 and 15 cancel out completely, 31. So now we're going to subtract 10 on both sides. Bring down my 9x equals 31 minus 10 would be 21. Divide by 9. And so x is equal to 21 over 9. But we do realize that both these numbers, you can divide them by 3 and simplify it. So divide by 3, and we should really get 7 over 3 for our final answer for that one. Okay, here you have a similar problem where we have a 4, a 5, and a 20. And it turns out that 4 times 5 is 20. So we're going to choose 20 to be our least common denominator. So 20 times 1/4 plus 20 times 4x over 5 equals 20 times 11 over 20. Okay, 20 divided by 4 is 5, times 1 is still 5, plus 20 divided by 5 is 4, times 4x is 16x, equals, these 20s are going to cancel out completely and just leave an 11. We're going to subtract 5, cancels out. So I have 16x is equal to 11 take away 5 would be 6. And then divide both sides by 16. And x is equal to 6 over 16. But both those numbers are even. So if you divide by 2, like that, you're going to get 3 over 8. Okay, this example, we have a couple 16s and an 8, so the least common denominator would definitely be 16. So 16 times 11x over 16 plus 16 times 7x over 8 equals 16 times 5 over 16. Okay, so these 16s cancel, so I'll just bring down my 11x. 16 divided by 8 is 2, times 7x would be plus 14x equals, these cancel completely, and it's just going to be a 5. So now I have 11x and 14x, which is going to make 25x equals 5. We're going to divide both sides by 25. And x is equal to 5 over 25. But we can divide both those by 5. And we get 1 over 5 for our final answer for that one. This one, we got a 3, and a 12. So 12 would be our common denominator. So 12 x over 3 minus 12 times 7x over 12 equals 12 times 2/3. Okay, 12 divided by 3 is 4 times x is 4x. These two 12s are going to cancel completely and make it a negative 7x or a minus 7x equals 12 divided by 3 is 4 times 2 is 8. Okay, 4x take away 7x is going to give me a negative 3x is equal to 8. Divide by negative 3 both sides. And x equals negative 8/3. And that one's done. And then we have this one. 5, 10, 5. So 10 would be our least common denominator. So we're going to multiply everything by 10. X over 5 minus 10, 3x over 10 equals 10 times 1/5. All right, so 10 divided by 5 is 2, times x is 2x. These 10s completely cancel. Negative 3x minus 3x equals 10 divided by 5 is 2, times 1 is still 2. 2x minus 3x is negative 1x. Is equal to 2. Divide both sides by negative 1 to get rid of that negative. And x is equal to negative 2. All right, now we have ones where we have some equations and we have some fractions with parentheses. So this time we want to distribute. So we're going to distribute this 1/2 to both of these guys over here. We're going to leave the 2x plus 3 alone and see how this is going to work. 1/2 of 6 is 6 times 1 divided by 2. So 6 times 1 is 6, divided by 2 is 3. Half times 4, 4 times 1 is 4, divided by 2 is 2, so plus 2x. And so now we have an equation with variables on both sides, and so I'm just going to solve it the way I normally do. Minus 2x. These cancel, and I bring down my 3 is equal to 3. So what happened here? Well, it looked like the variables canceled and it left a true statement, 3 is equal to 3. So when that happens, we can say that since that is a true statement, the variable's canceled, any value you put in for the x is going to make a true statement. So this is all real numbers, like this. And remember what letter stands for the set of real numbers, and that is this fancy R, like that. Okay, here's another one. Again, we have a fraction times parentheses here. So we're going to distribute. We're going to leave this alone. So 1/5 of 10. 10 times 1 is 10. Divided by 5 is 2. 2x. Okay, then minus. 15 times 1 is 15. Divided by 5 is 3. still equals 3 minus 2x. Okay, this looks very similar on both sides, but it's really not. So if I add 2x to both sides, I really have 4x over here minus 3 is equal to 3. If I add 3, then I have 4x is equal to 6. And if I divide by 4, I get x is equal to 6 over 4, and that's going to reduce down to 3 halves after I divide both of them by 2. Okay, again, we have parentheses with a fraction on the outside, so we need to distribute. Okay, so we need 1/4 of 60. So 60 times 1 is 60, divided by 4 is 15, plus 16 times 1 is 16, divided by 4 is 4x, still equals 15 plus 4x. So now I look at that and I see it already. The left side and the right side are identical. So if that ever happens, it's all real numbers. And again, you can put that little r there. And even if you subtracted 4x on both sides and 15, you'd still get a true statement. 0 is equal to 0. And you're still going to get all real numbers because the variables are going to cancel out. It's a true statement. Okay, let's try this one. 1/2 times 12 and 1/2 times 4. Okay, so 1/2 of 12 is definitely 6x minus half of 4 would be 2 equals 14, take away 10x. All right, so what I'm going to do is I'm going to add 10x to both sides. Cancel those. 10 and 6 makes 16x. Minus 2 is equal to 14. Get it down to a two-step. Add 2, add 2. 16x is equal to 16. Divide by 16. And I get x is equal to 16 over 16 is 1. Okay, this is another one, except now we have to distribute on the right-hand side. So the 5x plus 2 stays. Half of 10 is 5. Half of 4 is 2. Okay, and I'm looking at that, and I see again, the left and the right-hand side are equal. So if that happens, they're identical, all real numbers. Or you could put that r there for all real numbers. Okay, this one, I've got to distribute on both sides. So we'll deal with the left-hand side first. Okay, so this one's going to be a little trickier. Let's do this. 24 divided by 4 is 6. And 6 times 3 is 18. So all of that is going to be equal to 18. Minus 8 divided by 4 is 2. Times 3 is 6. Equals. Okay, let's go ahead and distribute this 2. That would be 10x plus 2. All right, I'm going to add 6x to both sides. So I have 18 is equal to 16x plus 2. Subtract 2. 18 take away 2 is 16 is equal to 16x. Divide by 16. And x is equal to 1 again. 16 over 16 is 1. A couple more. This one we're going to go ahead and distribute the 1/2 to both these guys. So, and it's negative. So half of 30 is 15, but that's negative. So negative 15x. Okay, half of 18 is going to be 9, but I have two negatives here, which are going to make a positive 9 equals positive 9 minus 15x. All right, I'm looking at that, and right now it doesn't look like it's identical yet. But if I add 15x to both sides, the two 15x's cancel out because they're additive inverses, and I have 9 is equal to 9. So the variables canceled and left a true statement, so that means it's going to be all real numbers again. All real numbers. Now, if it ever has the variables cancel and it leaves a false statement like 9 is equal to 8 or 0 is equal to 1, then it'd be no solution. That one's all reals. This one, the last one, always has to be the more complicated one. So we could do this. I know we have this and we really want to distribute that, but this one's perfect for clearing out fractions. So you have a 2, a 3, and a 6 right here. Let's go ahead and multiply everything by 6 and see what happens. So 6 times 1/2 x plus 6 times 1/3 times x minus 6 equals 6 times 5/6 x plus 6 times 2. Looks like a lot, but let's see how this is going to shake out. So 6 times 1/2, or 1/2 of 6 is 3x plus. Okay, so 6 and 1/3 actually are going to make 2, aren't they? So I'm going to actually write a 2 here, still x minus 6. I don't want to do too much at once. Equals, these two 6's are going to cancel out completely and leave me with a 5x, and that 6 times 2 is 12. Okay, so now I got rid of all my fractions, and now I'm going to distribute this 2 to both these items here in the parentheses. Okay, so that'll be my next step. So I have 3x plus 2x minus 12 is equal to 5x plus 12. Okay, so I've got this side over here that I can kind of clean up and add these two together. So if I add these two guys together right there, 3x and 2x make 5x minus 12 is equal to 5x plus 12. So now this is interesting because it has the same 5x on both sides. So if I subtract 5x on both sides, these cancel, but look what happens. It leaves me with a negative 12 equals 12. Now that's a false statement. That's not true at all. So the variables canceled, left me with a false statement. So like I just said before in the last problem at the end, this one is going to be no solution. And you can also use the empty set symbol like that for your solution. All right, so remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.